All right, welcome to the video where you're going to learn how to graph radical functions. You should have picked up the paper from class today, so if you don't have it, you can just kind of follow along. There is some writing that I tried to avoid having you write everything, so I'm going to talk through some of those points just so you know. So let's go ahead and get started. The first one says the square root function. We want to know what the parent equation is of that function. So we're going to start out, this is number 1. Where it says the square root function. So on the first blank, it should say y equals the square root of x. So the next line says, what are the coordinates for the 3 major points? So the 3 major points that we're going to be talking about today are the locator point, the x-intercept, the y-intercept. And so we'll see what all of those are in just a second. But because we're using y equals the square root of x, we haven't done a lot of graphing for that yet, so we're going to make a quick table. You may remember doing this from the beginning of the year in your foldable. You might want to reference that. But I'm going to specifically choose x values that I know the square root of, because if I generally put like -1, 0, -2, 0, any of those kinds of numbers, I don't necessarily, I'm not able to find the square root of them. In fact, I can't find the square root of a negative number because we actually want to plot these points, and if we found the square root of a negative number, they'd be imaginary. We wouldn't be able to plot them. So I'm going to erase this, and I'm going to choose points that I actually already know the square root of. So I know the square root of 0. I know the square root of 1, of 4, of 9. There's some more, but this is all that's going to fit on our graph. So you can plug other points in and then find them with your calculator if you'd like to. But this is going to be the easiest way to do this for right now so that you understand the gist of this. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So go ahead and plot those points on your graph. Because I don't have actual graph paper, mine's going to be less accurate than yours, but you should have a pretty good idea of what this is going to look like. So I'll have 0, 0, 0, 1, 1, etc. So again, you should be doing this on an actual graph, but it should look something like this. So we can look and see, well, the locator point is this point here. So again, it's kind of the equivalent of like what a vertex is from a quadratic. So the locator point will be 0, 0. In this case, 0, 0 is actually the x-intercept and the y-intercept. So that's important to know. So as you look further, down your notes, you'll see that we need to figure out the domain and the range. So the domain in this case, the x values, that's going to start at 0 right here, and it's going to go all the way to infinity. So our domain is 0 to infinity, and we're including 0. The range, let's see if I can choose another color here. The range is going to be the y value. So the lowest y value is 0, and it's going to go all the way to infinity as well. So this will be 0 to infinity. The x and y-intercept we just found, so you can just write those, and those are also the origin 0, 0. And then the square root function is the inverse of y equals x squared. So we talked about inverse, it's the undoing function. However, the inverse isn't going to be the exact reflection of this, so we're really just looking at the inverse from 0 to infinity is what that gap fills in. So what we're saying here is that we actually can't plug in any number for x. We can only plug in numbers that are 0 or greater. So that's that one. And so these are going to transform just like any of the other graphs that we talked about, so we'll go to that later. But I for a second about cubed root function. So this is this should be number 2. I think it's still listed as number 1 on your paper. So the parent equation for a cubed root function is just y equals the cubed root of x. And we're going to graph that in a second. So again, we want to find the locator point, the x-intercept, and the y-intercept. And in order to do that, we're going to have to graph this. And in order to graph this, we need to have a table. So the difference between the cubed root functions and the square root functions is that with cubed root functions, we can include negative x values. So for instance, we can take the cubed root of negative 27 because negative 3 cubed would give us negative 27. So that's not the case if we're talking about square root functions. I can't take the square root of a number, but I could take the cubed root of the number. So the cubed root of negative 27 is negative 3. I'm going to choose other numbers for x that I already know the cubed root of. So I know the cubed root of negative 8. I know the cubed root of negative 1, of 0, of 1, of 8, and then 27, which I can't, well, here, I'll shorten this a little bit. And of positive 27. So the cubed root of negative 8 is negative 2. The cubed root of negative 1 is negative 1. The cubed root of 0 is 0. The cubed root of 1 is 1. The cubed root of 8 is 2. And the cubed root of 27 is 3. So you can pause the video as you graph that. I'm, again, just going to graph kind of what the general gist of this is going to look like, just so that you can get an idea of this. So I'll just graph this in another color. So it should look something, and again, I don't have graph paper on this app, so it should be something that looks pretty similar to this. So as you can see, and you can pause it as long as you need to for that, but I'm going to move on. The locator point is going to be this point as well. So generally when we're talking about parent functions, the locator point is going to be 0, 0. And in this case, it's also the x-intercept and the y-intercept. So those are kind of the 3 points that we always want to pay attention to. The domain in this case is all real numbers. So we can plug in any number and find the cubed root. So if you choose any number, positive or negative, and take the cubed root of it on your calculator, it'll give you an actual real number. It won't be imaginary. And the range is going to be the same thing. So I can get any number for the y values. And so then at the bottom it says the cubed root function is the inverse of, and that should be y equals x cubed. So it's the undo function of y equals the cubed root of x, which should make sense. So we're going to move on to the back side. And so part 2 says we use the equation y equals a times the square root of x minus h plus k to show the parameter changes from the square root function. How would each of the following graphs change in relation to the parent graph? So what I'd like you to do here, which is a little bit different because this is a little harder to visualize, and I would actually plug these into your calculator as well. So I'm on part 2 at the back. So the first one says y equals the square root of x minus 1. So that minus 1 is inside the square root function. So if we kind of come back to this, y equals a times the square root of x minus h plus k, you guys know exactly what happens here because we've been doing this all year. So a is going to stretch or compress. It's also going to reflect. H is going to move it right or left, and it's going to be the opposite of what we think it's going to do. And k is going to move it up or down. So with these functions, what I'd like you to do is identify a, h, or k if it's changed. So in this case, we're subtracting 1 here. So our h value is 1, which means we're going to move to the right 1 unit. Okay? So graph that on your calculator so that you can see that it has indeed moved 1 to the right. You should see a graph that looks like this. All right, so for the second one, y equals negative 8 times the cubed root of x. You should see a graph that looks something like, it's going to actually be the opposite, so it'll look something like this. That's going to actually go through the origin, but I can't really get that on this app, something like that. So it'll be stretched out. So it has reflected because the a value is negative 8. So it's reflected, and it's also vertically stretched by a factor of 8. So again, just plug that into your calculator so that you can see that it's stretched vertically. The last one, I'm going to just minimize this. The last one says y equals 3 times the square root of x minus 9 plus 4. So we've got a lot going on here. So I'm going to just identify my a, h, and k. So my a is 3. my h is 9, and my k is 4. So also just remember it's the number that's being subtracted. So the h is 9, not negative 9. So my a value has vertically stretched it. Again, I would plug this into your calculator so you can actually see the graph of it. Vertically stretched. By a factor of 3. 9 has shifted it right, 3. And the 4, as the k value, has shifted it up 4 units. Okay, so we'll move on to the next one. So state the domain and the range of each of these functions. So I'm going to have you pause the video here, and I'm going to give you the answers for each of these, but I'd like you to look at your calculator for these before you actually check them. So you want to think about, where does the x value start, where does it end, and again for the y value. So I'm going to go ahead and give you the answers for these, but you need to look at your graphs to make sure that you understand why they are what they are. So A, I'll just have the domain here and the range over here. So A goes from 0 to infinity, and the range also goes from 0 to infinity. So it just stretches. So again, stretching doesn't affect the domain or the range. For part B, it's shifted 2 to the left, which you should see from the equation. So this is going to be -2 to infinity, and the range should just stay the same, 0 to infinity. If it shifts to the left, it's not going to change the range. Part C, this one's a little hard because there's a lot going on here. So the domain is going to go from 1 to infinity because it's shifted 1 to the right. The range is going to go -infinity to -3, and that's because it's flipped over. So it's actually facing down, and it's moved 3 units down, so it's going to stop at -3. D is all real numbers and all real numbers. So any cube root graph is going to have a domain and a range of all real numbers. So E is going to be the exact same thing. And then there's just one practice problem for you here, and I'll give you a quick hint, but I want to see this on your paper when I check notes tomorrow. So, and we'll finish. So you just have part A there, but we'll do some more in class tomorrow. So if you look at y equals negative square root of x plus 3, tell me what the a value is and what the h value is. So you should be able to see that the k value has not changed. So go ahead and give me the domain and the range. What you're going to need to do first is graph this. And in order to graph this, you need to make a quick table. I've given you a little bit of space on the side there. So x and y. And again, I would specifically choose values for x so that whatever's inside this radical sign, you're going to be able to take the square root of really easily. So I'm going to give you some x values, but I want you to think about, why am I using those x values? And after you go through and plug these in, that should be a little bit more obvious. So the x values I'd like you to use here are -3, -2, 1, and 6. So just 4 points, but you should know what this looks like given the a and the h. So bring that in tomorrow, and then we'll go ahead and finish this after that. That's it.